Alright guys, look what we have at the board today. This is redox reactions in chemistry. You know, this topic always confuses a lot in chemistry, like it's an obstacle in chemistry. So I'm going to be trashing it today. Just pay attention and listen. This is a diachromate. This compound is a diachromate. This is a ion 2. This is chromium and this is ion 3. So now, if you want to balance this kind of redox equation, you are going to split the reactions. You are going to find for this and this and this and this. That's what I mean by splitting the reactions. So now let's go. Before you find for this and this, which I'm going to write out now, you need to find the oxidation number of chromium. That's why I told you that oxidation number is very important. You need to find the oxidation number of chromium so that you can be able to use it here. Because I'm not going to use this compound with chromium. It's not going to work that way. Now let's find the oxidation number of chromium. Let's go. So we're going to find the oxidation number of chromium in this compound called diachromate. Now let's go. I have two atoms of chromium here, so I'm going to write 2Cr equals to, listen, oxygen has -2 as its valency, so I'm going to write this 7 multiplied by that -2 equals to 2. Normally I'm supposed to write 0 here, but there is 2 up here, and this 2 up here is positive. So now I'll go again. 2Cr will be equals to 7 times -2 will give you what? -14. Then this equals to will change to what? Plus. So it will now be +2. I'll go again. 2Cr will be equals to minus plus is what? Minus. So it will now be 14 minus 2 equals to 12. Now the total oxidation number in this 2 chromium is 12. You understand? But we want this chromium to have their own different oxidation numbers. So in order to do it like that, you're going to divide by these 2 so that each chromium has its own oxidation number. You understand? They want to share it. So in order for them to share it, I'm going to divide by 2. It will now be 12 over 2. These 2 here will give you 6. So each chromium, like I have 2 chromium now. So number 1 chromium has 6 electrons. Sorry, has 6 oxidation number. Then the second one has 6. So 6 plus 6 is 12. That's what I mean. You understand? So I have 6 oxidation number for each chromium here. So that will take us to the next side. So as we have find the oxidation number of chromium now, you are not going to write its own brother with it along with it. We are now splitting the reaction now. Now this chromium now has 6 oxidation states. You understand? So from 6 now to 3, is it decreasing or is increasing? Listen, it is decreasing. It is undergoing reduction. So this should tell you that this chromium is working as the oxidizing agent in this question. You understand? Because if like this is +6, 6 to 3 now is reducing. So once it is reducing, the agent it will become is called oxidizing agent. Now some of you will rush and go and write 3 electrons. Normally it is 3 electrons that's supposed to be, because it is decreased from 6 to 3 by that is 6 minus 3 is 3. But listen, this 2 is going to be affecting that 3. I know that 6 is going down and it is remaining 3 electrons, but this 2 here is also going to be affecting it. So this 2 will be multiplying that 3, and if that 2 multiply that 3, it is going to give you 6 electrons. Look at what I mean. 6 minus by 3 will give you 3 electrons, right? Yeah. Then these two shows that there are two chromium in this compound. So you need to use that 2 to multiply that 3 so that it will be balanced. You understand? So that's why I'm going to multiply by that 2. It will give me 6 electrons. So I have 6 electrons here. So next thing, once you are balancing a redox reaction and you see anything like oxygen in that question, what is showing you that you must invite water and hydrogen to that equation. So let's go now. So I'm going to introduce water. That is 7. So I'm also going to introduce what? Hydrogen, because 7 times 2 is 14 plus 14 hydrogen. I understand how the thing is flowing now. So let me find for iron. That is iron 2 plus iron 3 will give me what? Now iron is increasing from 2 to 3, so they are the reducing agent because it is increasing. Remember, when it is increasing, it is called the reducing agent. While it is decreasing, it is called the oxidizing agent. That's the trick there. So this one is increasing by 1, so it is the reducing agent. That is 1 electron. You can decide to remove this one and just write it like this. There is an invisible one here, but let me just write it. 1 electron. Now what next you do? You are going to make use of their electrons. This one has 6 and this one has 1. You are going to multiply. You are going to find the LCM. The LCM I mean is that 6 multiplied by 1 will give you 6, and 1 multiplied by 6 will also give you 6. You understand? So when you reach here, assuming that is 2 that is here and 3 is here, you understand now? I'm going to find the LCM between 2 and 3. That is, what I mean is, if 2 multiplied by 3, it will give you 6, and 3 multiplied by 2 will give you 6. You understand? But here now it is 6 and 1. So 6 multiplied by 1 will give you 6, and 1 multiplied by 6 will give you 6. So we are going to now add them together. Adding them together, we are going to have if you notice, I did not write anything here because there's an invisible one here. This one will go here. 6, everything about chromium, the electron we got in chromium will be multiplying iron side, and the electron we got in iron side will be multiplying chromium side. That's the trick. So this one is multiplying this, and it will give you dichromate plus. Now listen, if you reach here now, you are going to bring this hydrogen down here, plus 14 hydrogen. You understand? Plus, you are going to bring down the iron 2, 6 iron 2. You understand what I mean now? You see now that this is electron of chromium side is now multiplying the iron side, and this one electron is multiplying the chromium side. So there are invisible one here that we cannot see. So 6 electron will now give us chromium plus 6 electron of iron 3 plus 7. As you can see, it is balanced now. Balanced. Okay. So this is the trick. This is the trick. You know that this chromium has been reduced to 3, and this 2 is multiplying it to give you back 6. You understand? I have plus 6 as the oxidation state when I balance that when I balance it that time in the video. So this plus 6 now has been reduced to 3, and this 2 is also multiplying that 3, which is the thing is still 6. So in order for me to balance chromium, I need to add 2 here, so that 2 times 3 will give me 6, and 2 times 3 will also give me 6, because it is now 3 that is 0, will also give me 6. So chromium is balanced. So if they ask you now, they can use this to ask you question. They can ask you in JAMB or in any other question. They will ask you the coefficient of hydrogen in so compound is dash. It is 14 hydrogen. They can ask you the coefficient of water in this equation is what? It is 7. So if you cannot balance it, there's no how you're going to know the coefficient unless you guess, and guess is by luck. You understand? So this is all about redox reaction. You understand? So which one is the reducing agent and which one is the oxidizing agent? So this one is the oxidizing agent because it is reduced, and this one is the reducing agent because it is increased. So let's treat another example. I hope you understand this. Let's treat another example. Now, if you meet this one, iron plus copper sulfate, we react. Iron, this is iron 2. Iron 2 react with sulfate. You know they have 2 as their valences, so they're going to interchange each other. It will give me iron sulfate plus copper. So you can see now that you are not going to do it as I did for the other one, because oxygen is balanced here and oxygen is balanced. You are not going to introduce water. Listen, before you go and introduce water, you are not going to introduce water in this aspect. Now, what you will do if you still a kind of equation like this is you are going to make use of your reactive series, which is potassium, sodium, magnesium, calcium, magnesium. Sorry, what am I even writing? Potassium, sodium, magnesium, calcium, aluminium, zinc. There are many. Okay, tin, lead, hydrogen. There are many. Just master that reactive series. This is the only one I can recall for now. Then you can see that okay, zinc ion before zinc ion before tin before lead continuously. So zinc, potassium, sodium, magnesium, calcium, aluminium, zinc ion, hydrogen. So just master your reactive series. This is the one I can remember for now. So all the metals up can be able to displace the metals down. So iron is up and copper is down. So iron can displace copper. That means iron will be the reducing agent and copper will be the oxidizing agent, even though the two of them are metals. But listen, since iron displaces copper in this reactive series, then that means iron is ready to lose electrons more than copper. That means iron will be the what? Reducing agent because it is increasing, and this one will be the oxidizing agent because it is being reduced. You understand? So listen, oh, you only use your reactive series to predict this if the equation is in this format. If it is in the format of the one that I did before, you are not going to use this reactive series. So thank you for watching. If you find my video interesting, please click on the follow button. And if you want more of my videos, you can follow me on YouTube, search Medicnator, and watch most of my videos. Thank you for watching.